Question number 61. Correct order of bond angle for the given compounds is. We have different compounds here, and if you look at the given compounds, first we have H2Te, H2S, and then we have H2O. These three compounds are there. These are the hydrides of group 16 elements. Oxygen, sulfur and tellurium, and in all of these cases the central atom has two lone pairs. In case of water, two lone pairs are there at oxygen atom, similarly on sulfur and tellurium also. Due to the small size of oxygen, there is more lone pair repulsion, and due to that repulsion the bond angle is more. In case of sulfur, size is comparatively larger, less repulsion is there, and that's why bond angle is less. Finally, in case of tellurium, the bond angle is least. It means the correct order of the bond angle is maximum for H2O, then for H2S, and then H2Te. This would be the order. So this order that I've just written here is correctly given in option 3. And that's why this is the correct answer for this question. Now let's take question number 62. The correct order of solubility is. Here is the solubility of barium sulfate, and barium sulfate is compared, and it is given that beryllium sulfate has more solubility as compared to BaSO4. Again, beryllium sulfate has less solubility as compared to magnesium sulfate. Then beryllium sulfate has more solubility as compared to barium sulfate given here, and further MgSO4 has less solubility as compared to BaSO4. I just want to write here the correct order of the solubility of the sulfates of alkaline earth metal given here. Beryllium, barium and magnesium. The correct order is BeSO4. This is most readily soluble, having maximum solubility. Then there would be MgSO4 and then BaSO4, and that is due to the relative sizes of cation and anion. Beryllium sulfate is most soluble, and on that basis, if you look at the given options, you will see that BeSO4 having more solubility as compared to BaSO4 is correct. Further, BeSO4 has less solubility as compared to MgSO4 is wrong. BaSO4 has less solubility as compared to BaSO4. This is also wrong. Further, MgSO4 has less solubility as compared to BaSO4. This is also wrong. Only one option is correct, that is option 1. Question number 63. The oxide which will not react with NaOH is. We should know that generally non-metallic oxides react with alkali or amphoteric oxides react with alkali. If I talk about Al2O3, this is amphoteric oxide. It can react with an alkali NaOH to form salt and hydrogen. Similarly, if I talk about SiO2, this is acidic oxide. It will also react with NaOH. And further, BeO, this is beryllium oxide. It is also amphoteric in nature. It can react with NaOH. But calcium oxide, it's a basic oxide and it will not react with NaOH. That's why the correct answer is option 2. After this, here is question number 64. The dead burnt plaster is. If you heat gypsum above 200 degrees Celsius, then you will obtain dead burnt plaster. That is basically anhydrous calcium sulfate. And that's why the correct answer is option 4. Anhydrous calcium sulfate, that's given here. After this, next question that we have. The species which does not have p-pi-d-pi bonding is. P-pi-d-pi bonding occurs in those compounds in which empty d orbitals are present. If I talk about this SO3 2 negative ion, sulfite ion, there is the possibility of p-pi-d-pi bonding. In phosphate ion, possibility of d-pi-p-pi bonding is there. In S2O3 thiosulfate ion, there is the possibility of p-pi-d-pi bonding. But in case of CO3 2 negative carbonate ion, this possibility is not there. The question is that why it's not there? Because in case of carbon and oxygen, in both of these elements, d orbitals are not present. That's why this type of bonding, p-pi-d-pi, is not possible in this case. And that's why I'll choose this as the correct option. Now, after this, it's a turn for question number